Hello everyone. Welcome for today's session on augmented reality and industrial automation using Internet of Things. So we have a presenter, Mr. Raju Batulla from Design Tech team, and Mr. Ujjwal Patel also from Adani Group. So before going ahead with the today's presentation and today's webinar, I will quickly introduce this tool to you. We are executing this session through a GoToWebinar tool. Just to update you, like it won't be a one-way communication. So if you have any query in between, if you want to ask any question, you can just type your query in the chat window so that we can unmute you, so that we can answer your questions also. And if you want to directly communicate with our presenter, you can raise your hand so we will unmute you. Okay. So it's good if you can type your queries in the chat so that we can answer it one by one. Okay. So now Mr. Ujjwal Patel will take the initiative and start this thing. So Ujjwal sir, so I'm just
Yeah,
handing it
right.
over to you. Yeah. Yes, sir. Yeah.
Sure.
Yeah.
Very good
Yes, sir.
morning, all of you. Very good morning, all of you. So,
Good morning,
welcome
sir.
to this. Good morning. Welcome to this webinar on industrial automation using Internet of Things and augmented reality. So, I am basically working as an assistant professor in Department of Electrical Engineering at Adani Institute of Infrastructure Engineering. Right. So, briefly, I will like to introduce my college. 1 minute, please. Right. Briefly, I will introduce my college that we are running mainly 1 minute. Some problem. Okay, we are running mainly three courses: electrical engineering, civil and infrastructure engineering, and information and communication technology. And we are basically affiliated with the GTU. And these are the key highlights of our institute. Our institute is having world-class infrastructure as far as both classes and laboratories are concerned. In our institute, all the faculties are well qualified. Majority faculties are PhD, and one of the key feature of our institute is highest placement opportunities we are giving at our institute, right? So, what will be the outline of this particular webinar? So, in this webinar, first of all, in first few minutes, I will be giving you the prerequisite and the brief introduction about the IoT and related areas. Then the next sessions will be taken by the delegates from the Design Tech Systems, right? So they will be exploring you about brief introduction about the Industry 4.0, then what is IIoT and AR, and how it can be implemented, and then we will have some question answer session, right? If you want to explore this in detail, then also you can go on to this link, right? Okay. So now, what is IoT, right? Whenever we are learning anything, we should have the knowledge about what is it, where it can be implemented, and how it can be used, right? So what is IoT? So that we will see. So IoT is nothing but it is a one kind of cyber physical embedded systems using which we can control anything from anywhere, right? So what do you mean by embedded systems? Means it is a combination of hardware and software, right? There will be some hardware, means there will be some sensors, actuators, and controllers, right? And there will be software will be written into the controller or PLC, right? And so it is a combination of hardware and software, right? And it is connected through internet, right? And through internet we can monitor and control from anywhere in the world, right? So that is the beauty of IoT. Using IoT we can control anything from anywhere. So now let us see, this is the conventional industrial automation systems which are in operation up to till date, right? Majority of the these particular sensors and actuators are connected with the PLC, right, through hardware, right? So these sensors and actuators are connected with the PLC, and if we want to monitor this particular whole operation, then we can monitor either in HMI or we can also monitor in the SCADA systems, right? So majority of the control will be done at the local end, right? So now how we can have the nowadays, because of the introduction of IoT, right? So this particular conventional industrial automation can be converted into the IIoT, right? So what is IIoT? In IoT, these industrial automation systems can be connected with one particular Wi-Fi module, or it is also called the IoT gateway module, right? And through IoT gateway module, we can transfer this data through anywhere in the world. That data can be transferred to either computers, or either it can be also transferred to the mobile systems, right? So that we can monitor as well as control from anywhere in the world, right? There are many clouds providers are there, like ThinkSpeak, Google, Amazon, IBM, right? So many cloud providers are there, service providers are there, right? So this is the overall structure, or we can say basic components of industrial IoT, right? Okay, so these are the basic structure of industrial IoT system. All sensors and actuators will be connected with the PLC. PLC will control everything. It can be also have the local monitoring using HMI and SCADA, and it can be also have the remote monitoring using the IoT gateway module, right? So now let us see the different applications of IoT, right? So this particular, there are different applications are there for the industrial automations. Uh, first and foremost applications of IoT is in the home automation, right? So I am not limiting the applications of IoT to the industry, right? I am also exploring the applications of IoT in other sectors as well, right? So one of the key applications of IoT is in the home automations, right? So in home we can control lighting, we can also control its intensity, we can also control the speed of any fan, and we can monitor any devices through anywhere in the world, right? So that is the home automation. Second, we can also have the building automation. In building automation, we can control everything for whole building as well, right? Like water purification systems, water distribution systems. We can also control the car parking systems. We can monitor each and everything like a security, and everything we can monitor and control, right? We can also monitor the power consumption in the building from anywhere, right? So that is the IoT in building automation. We can also have the foremost application, that is industrial automation. In industries, we can control each and every parameters using this particular technology, right? In industry, we can control whole productions line from anywhere. We can also monitor the quality control from anywhere. We can also have the inventory management, and we can continuously track and monitor, and we can also see about the logistics, right? Whether, and we can also track different parameters, right? So this is the applications of IoT in the industries, right? So with this we will be exploring in detail in the this webinar only. Next, IoT can be also helpful in the healthcare sector, like in this corona pandemic. It can be also very much helpful, right? We can order anything like medicine. We can also contact the doctors from anywhere. We can also order the medicines, and we can monitor the patients from anywhere in the world, right? So these are the different benefits of IoT in healthcare sector, right? Okay, so ultimately, if we are implementing IoT in healthcare, we can have the doctor at our doorstep, right? So we can call the doctor from anywhere in the world, right? And we can have the major advantage of these disruptive technologies, right? So IoT devices are widely invented nowadays by many industries. These are the top 10 smart IoT devices which are available, right? So this is just for your knowledge point of view, right? So many IoT devices are available. If you want to know about each and every kind of devices, I will share this particular PPT, and this link is available, right? So next, IoT can be also used in the robotic applications. Nowadays, robots are frequently used in the industries. These robots using IoT can be controlled from anywhere in the world, right? So these are the potential advantages of IoT. So these are the IoT application scenario, right? The majority applications are in the field of manufacturing. IoT are extensively used in the electronics industries, for manufacturing the different parts, and IoTs are extensively also used in the automobile sectors, right? Other sectors are also increasingly using the IoT applications nowadays, right? So these are the world IoT scenario at present, right? So these are the different applications of IoT. It can be used in home, building, industry, healthcare, IoT devices, robotics application, and many more, right? So now we will see. So up till now we have seen what is IoT, where it can be implemented, right? So now we will see the potential benefits of the IoT, right? So we can monitor and control anything from anywhere in the world, right? It makes our life very much easier. Ultimately, the major advantage of this IoT is increased productivity, right? And we can have the global connect, right? So ultimately, each and every process will be optimized using IoT, right? So simultaneously, we should also analyze the risk. As whenever we are using any new technology, we should also analyze the risk associated with it. So which are the risks which we must need to consider, right? So there will be these are the some of the risks, right? Out of this particular risk, I had placed majority of the risk in the green zone, so they can be easily taken care of, and one particular risk I had kept into the orange zone, which must be taken care properly, right? So because of IoT, there can be the social isolation. We are ultimately dependent onto the technologies and the infrastructure, right? If it will be not there, then the whole system can be down, right? So, but the connectivity, if the connectivity is maintained properly, then there will not be any kind of problem. The privacy issue can be there, right? Because we are continuously tracked, right? In IoT, we are giving permission to access many things, right? So if the security is perfect, then there will not be any problem, right? So privacy and security are very important, and it must be taken care, right? Apart from this, one of the another important setback can be there, that is the latency also we need to take care. But nowadays, because of the invention of the 5G technologies, this latency problem I can say that it will be completely eliminated, right? So these latency problems will not be there in future, right? So nowadays some latencies are there of 1 or 2 seconds only, right? But in majority of the processes it can be uh, taken care, right? So these are the these which we need to consider, right? So these are the global IoT scenario. So in this, we can see that applications of IoT are increasing day by day, right? One thing I want to explore is this scenario, which I had come to know recently. This is the global IoT scenario as on 2019, December 2019, right? And this is the applications number of internet user as a percentage of country's populations which are connected uh, through the IoT devices, right? So here we can see what is the position of India, right? So he is here. This is India, right? India is in gray color, right? So in India, the applications of IoT is very limited, right? So this we must need to improve a lot, right? I even this source I got from reliable website, right? But I question this, right? But still I am exploring that we must need to improve our IoT infrastructure in India, right? So that's why we are conducting this webinar, so that all the stakeholders can be benefited, right? So other facets of IIoTs, IoT can be also combined with the AR, right? So in AR we can have the virtual model of anything, and we can monitor each and every parameter either, right? So using AR we can have the advanced level of control, right? We IoT can be also combined with the cloud computing, in which we can have the some advantages of clouds, right? We can use, for example, supercomputers of IBM, right, using cloud computing, right? So that is one of the major advantage of cloud computing, right? So blockchain can be also interfaced with the IoT. We can also have the advantages of AI and ML. for advanced control and monitoring, right? Right. So this I had given just a brief introduction about the IoT. Now the next sessions will be taken by the experts from the design tech systems. I am very much happy to welcome the Raju sir and his team. Uh, Raju sir is working as a national manager, technical support from the design tech systems. So I hand over to the Raju sir from design tech systems. Thank you all.
Yeah, thank you very much, sir. And thank you very much for attending our webinar on the latest technology. So to introduce myself, I'm Raju Battula, and I take care of the technical support for the PTC products and various other product lines, so which I'll be just showing about my company profile as well. So accordingly, we'll just take it forward. And with me, my team, Pritesh Kusumkar, he takes care of IoT. And after that, Mr. Santosh Prasad, he is going to tell about augmented reality. So these are the two solutions which we are going to present today. So various other solutions, we do have it within Design Tech, so which we are going to discuss in our coming presentation. So thank you once again. And before I just start, just try to be safe. So there's a COVID-19 situation. We are trying to just do this webinars for the benefit of everyone of you. Design Tech Systems Limited, we are almost tied up with about 12 different portfolios, basically for the benefit of the customers. So we want to just come out with the solutions which is going to be the best of the class in the industry. Like we are tied up with PTC with various portfolios, which I'll be just discussing now. Altair, we are the All India distributors for its simulation suite of products. And we are the distributors for even Stratasys and SolidScape. Basically, they are the RP solutions, rapid prototyping. So anyone wants to work with, say, plastic, 3D print with various materials, basically towards plastic, or even SolidScape, where we are trying to use here as wax, and you can achieve an accuracy of 6 microns. So it is really tough for a manufacturing person to achieve a 6-micron accuracy, which we can get it from SolidScape. And OpenMind, it is the world's best CAM solution. So with this particular solution, we have a software called as Hypermill. So a German company and one of the best solution towards CAM. And for IBM, so we are having some educational tie-up with IBM. I don't take care of IBM, so I have no much knowledge on this particular solution. But yes, DCS, which is dimensional control system, especially for mechanical engineers, where you can understand about stack-up tolerancing. So any design, you try to give it with GD&T, and that GD&T needs to be validated. So we try to use here called as DCS, dimensional control system. This is the world's best solution. And ESI for its welding simulation. So once the welding is done, or before welding is done, you want to validate the welding process. So ESI is used. And MathWorks for its mathematical simulation. So we try to use that. So we are the distributors for that as well. So Rosetta Stone is an education solution. Basically, it is a education, business, and public sector people try to use it. And we are tied up with Rosetta Stone for Asia Pac region, not in India. And Bentley, so once again, it is into plant designing and all the large architectural and civil area. We are tied up with Bentley. And Synopsys for its security solutions. So it is the Fortune 500 company. So one of the largest company in the world. So with which we are having the business alliances. And coming to about Design Tech Systems. So we are the top CAD/CAM CAE company in India, and with 21 years of experience and about presence in 9 cities in India itself, and close to Adani. Actually, we have our offices in Gujarat, and we are having our offices in Mumbai, and head offices from Pune. And various other places within the country. We have about 9 places, and also worldwide we have an office in US, Singapore, Hong Kong, Germany, etc. And with close to 750 strength, out of which about 450 plus are technical staff, with satisfied customers of about 2,200 plus and going. So it's not stopped here. So I hope every year we are adding up new customers here, and the satisfied customers. So that is the main mantra of Design Tech. Let me just tell you about Industry 4.0. So this is a buzzword. So rightly, Dr. Ujjwal Patel sir has told you about IoT. So actually, IoT is Industry Internet of Things. Now, I'd like to just focus something about Industry 4.0. So I thought of just playing a video. Let me just try out. I hope video is not audio is not coming out at your place. So I'm skipping this. You're having some pictures here. You can just answer yourself. No need to tell me. So you're having something called as an assembly line. You have something called as a digital industry. You have industry revolution and connected machines. So which one is the topic here? For example, the industry revolution. So there's the first one is the industry revolution. After that, so came with the assembly line. So because industry revolution is man invented the wheel, and the machine is industry revolution 1, and industry revolution 2 is an assembly lines, and later on come with an digital industry where the CNC machines or the NC machines, basically I don't call it as CNC but NC machines and all came into picture with industry revolution 3, and 4 is the connected systems. Now today we are trying to discuss more onto this 4th area, which is the connected systems. So this somewhat in short about industry evolution, industry 1.0, 2.0, 3.0 and 4.0. Every time the industry revolution has come with some world wars, but good industry 4.0 is nothing here. We are trying to just work with cyber physical systems and Internet of Things and networks. So this is how what we are trying to work today, that is industry Internet of Things or industry 4.0. So the 4th industrial revolution, so we try to say as we are witnessing profound shifts across all industries marked by the emergence of new business models, the disruption of incumbents, and the reshaping of production, consumption, transportation and delivery system. So whatever Ujjwal Patel sir has told, it is a similar thing, but in a simple format. There's a definition I can say about what is Industry 4.0. And products are changing. Now, earlier we used to call it as a product is very good and all, but today we are trying to call it as products are smarter because they are able to listen to us. So before what we understand or what we want to do it, so we are able to really tell them that before I understand, so they are trying to do it. So that is somewhat we are trying to use is called as smart connected products. So where data analytics or design for connectivity, additive manufacturing, augmented reality, these are some of the things which are coming out. So as per the various studies here, Industry 4.0 is a real-time high data volume availability through multilateral communication and interconnectedness between cyber physical systems and people. So where digitization and new technology, when we are trying to merge these two processes, so people think that just only connecting two systems is called as Industry 4.0. No, it is called as digitalization only. When we are trying to just include some new technologies here, like the manufacturing technologies, then we call it as an agile manufacturing or say Industry 4.0. So this was a slide which we started showing in the year 2018 and even before that 2017 and all, where when Industry 4.0 has really started coming out in India. So at that time we were telling that about 50 billion connected devices will be coming by 2020, and today we are on 2020, and you can just really see all these numbers which we are shown in 2017 and 18 are really right. So about 43 zettabytes, and it might be more than that, which we are trying to use the data monthly today. And in short, you can just look for yourself. Before lockdown, when we used to do the work from home was not really happening in those days. So before March or so. So now we are having some special packs called as work from home packs, which have been introduced by most of our service providers. So, and we are trying to consume each and every data of it. So that is what is data which is getting consumed today. That is what we are trying to work. And 72% of the companies agree that digital business model is critical for success. And 47% of the companies believe in traditional business model obsolete by 2020. Yes, today we are able to see that. So I hope now the business models are going to change post COVID. So these are some of the industry is trying to transform themselves. This about Industry 4.0, and the challenges and manufacturing expectations are rapidly transforming because workforce productivity has to be increased. Increased productivity and the operation complexity is going up day by day. Capacity utilization, that is each and every asset optimization has to be done. For example, I have 10 CNC machines and 10 CNC machines, each CNC machine, how much time it is trying to work. Say today I'm trying to work for 3 hours. So if I bought it for say 10 lakh rupees and only I'm trying to utilize it for 3 hours, so what the other 21 hours it is trying to do? So we have to just increase its capacity. So where I'll try to know, yes, that information has to come to me. So which machine is free or which engineer is free, so or whether the total productivity is coming out of the engineer. So these are the things we are going to understand about. And silos of information, like say I have a company in Gujarat, I have a company in Delhi, I have a company in say Maharashtra. So how everyone are trying to work on their own. Now how we are to just work together and improve quality zero defect, in the sense like a Japanese company, if you try to say that as for Six Sigma, about 1 or 2 components out of 10 lakh components has to be a defective, and what they do it is they send a defective component by creating a defective component. So that is what how Japanese try to work. And Six Sigma or say 5 Sigma or 3 Sigma, we are trying to work here. So how we are trying to do this, these are the challenges which are coming out to the expectations are coming out from the companies here. So with Industry 4.0 and navigating towards IT OT convergence, so we are trying to work today with the latest technologies here. So IoT is no longer a hype, and the companies has to start working with IIoT, Industry Internet of Things. So every part of the country is coming out with smart manufacturing is called in US, or Industry 4.0 by Europe, and made in China by China. So whatever it is, like 33% majority of the companies are coming out with IoT economic value. So this is what the factories are setting up today. Okay. So here the stages, how we are come out with Industry 4.0 development path. So the first is digitization, where computerization is going to come, and the next stage is going to be connectivity, which is the digitalization part comes out, and visibility, transparency, predictive capacity, and adaptability. So this is how the phases of design goes on with. So there's the stages of Industry 4.0 development path. So connected devices of Internet of Things, you can just connect anything. It might be a service provider, it might be operations, distribution, markets, just name a thing. So everything is connected today. So where you're trying to get the information. From my office, I can operate my AC in my home also. To that level of connectivity today it has come to. So connected machines to Industry 4.0, where embedded systems or network embedded systems, cyber physical systems, and vision Internet of Things. These are the levels of evolution which is coming out within Industry 4.0. So digital transformation, till now I've discussed something about what is IoT or Industry 4.0. Now the digital transformation, let us just try to discuss towards PTC. So PTC stands for Parametric Technology Corporation. So which is a global leader. So today across the globe, so as per the revenue, it is about 1.4 billion revenue in 2018 itself, and today you can just expect. And we are into various verticals. We are not in one particular vertical here. So we are in automotive or say aerospace. We have federal aerospace or electronics, industrial products, life sciences, almost every vertical we try to just operate with. So this is PTC globally. They are the leaders here today. And we are having the breadth of PTC solutions. So we are having 3D platform called as Creo, where we can do any type of designing modeling here. So the large assembly models or whatever you want, you can use with the 3D platform. We are having this PLM, product lifecycle management, using Windchill. And today, mostly we are going to concentrate only towards the last two. One is industry orchestration platform, or what we call it as THINGWORX today, and experience platform, so which we are going to use it by using augmented reality. So these are the two solutions what we are going to discuss about Industry 4.0. So these are the things like what we are trying to do. The first part we call it as Creo for CAD and Windchill for PLM, and we are having ALM, application lifecycle management, using Integrity, and we are having something called as service logistics. So various solutions are coming out with the yin yang method, where solutions and technology, where the digital twin comes into picture. So here, that's how we are trying to use the PTC as a solution here. When products are getting changed, for example, a product has been created first, and then the second stage is the product should be smarter, and later on I try to think that it should be connected product, because just going to a product and try to understand the information about the product is a bit old thing. Now I want to make the product as a connected product, because it has to connect to my system. But now we are trying to just make it as product system here, in the sense it might be a farm equipment, it might be planters or combine harvesters or tillers, which are going to get connected to your tractor. And the bigger equipment, when it comes to say the system of systems, so this is the level where today we are trying to work. We are not trying to work with one machine or two machines or three machines. We are trying to work with a company or an enterprise. So to this level, the products are getting changed, the requirements are getting changed from the teams basically, or the companies. So I'm not trying to focus specially towards only education here, as we have the teams from education and as well as from the companies. So that's the reason even the companies, what they are trying to face the problems. So that's the reason we are trying to bridge a gap between the colleges and the industry here. So especially for Adani. So I'll be just handing over to my colleague Pritesh Kusumkar. He is going to tell about THINGWORX platform, which is specially a connected platform using IoT as a solution. So over to you, Pritesh.
Thank you very much, Raju sir. Good morning, everyone. So I will take you through a solution called as THINGWORX, which is a IoT solution from PTC.
Just a second, there are a few people who are raised their hands, so
And you just see the chat box. No sound, no sound. At what time? Yes, 10:30. So I hope everybody is getting sound. So if anyone is not able to hear, please.
Ujjwal sir, is it okay? You're
Yes,
able to hear, sir?
Yes,
Okay.
it is okay to me. Yes, yes.
Right, sir. Right, sir. Actually, one with this, Mr. Nitin Jain. Few people, I think, three of them were not getting audio. Okay, so we'll just go ahead now. Yeah, thank you. Thank you, sir.
Okay.
So I will take you through the technical capability of product THINGWORX. Okay, so basically what drives any business outcome? So there are three principle of 3 P's. So smart connected products, so which drives critical product and service differentiation. You might have different products which works on field, and you want to monitor there are some key parameters. So that category is smart connected products. Then you have smart connected peoples, where we try to make workforce very productive and quality sort. Then we have smart connected processes or smart connected operations. So when you have a assembly line, it may be assembly line, it may be a manufacturing line, or it may be a whole factory, or it may be a group of factories which are connected to each other and which are able to communicate with each other, where you can monitor the efficiency of a single line to a whole plant or multiple plants. So these are three categories: smart connected products, smart connected people, and smart connected operations or processes. So what is unique offering from PTC? So for digital transformation, PTC has pre-built industrial solution which are ready to configure out of the box. So no need to you code your solution as per your requirement from the scratch, because it is a purpose-built platform, especially for keeping in mind industries. Then developed with unique industrial IoT solution framework based on the Think model. I will talk about the Think model in later slides. Uh, then built on base cloud platform and IoT services from Microsoft Azure. So PTC has partnered with Microsoft and Amazon as well for providing their cloud services. So key benefits of this digital transformation solution suite is driving business impact quickly, adapt new businesses context to stay competitive, accelerate application development. So these are the solutions for industrial enterprise. Start from your product service innovation, you're increasing your manufacturing efficiency. It might be a sales and marketing department, then your engineering excellence or service optimization. So different solutions which are available here. PTC solution frameworks start from your CAD design to managing your product data using PLM, which is a windshield solution. Then you have IoT solution THINGWORX for augmented reality experiences. We have Vuforia Studio. Again, PTC has partnered with Rockwell Automation and ANSYS as well. And as I said, for cloud platform, we have PTC is partnered with Microsoft as well as Amazon Web Services. So here is the breadth of the PTC solution for industrial IoT platform. So right from acquisition of data from your IT and OT system, then contextualizing that data with your existing, you might have some existing system for ERP or your PLM or MES or any system you might have. So whatever data you are getting from your IT system or your OT system, to have a proper contextualization, you can extend to that systems, other systems as well. Then have the capability of visualization all the data which you are acquiring, and performing analytics on that data. Then business process flow, UX composition, designing different UIs as per your requirement. Then domain specific logic compositions. Each and every business have their different business logics, so you can apply that logics to your applications. Then domain specific data model composition, industrial protocol translation. Nowadays there are very disparate data availabilities there in each and every industry. So not any industry is relying on single vendor for their equipments. They might have multiple equipment from multiple OEMs. So all these disparate data can be connected, and that protocol protocol translation can be done using this solution. And again, digital content management and remote access is one of the capability. So why THINGWORX? So as I said, it is a purpose-built platform specifically designed for industrial IoT, which includes connectivity, which is scalable and which is very secure. As per your business grow, you can scale it and use it. Then we have rapid development, deployment, and extensibility. So integrating with other systems, which enables your seamless development for quick and easy delivery of applications and AR experiences. And ultimate flexibility. There are different deployment options for your flexibility. Like you can deploy your application on cloud or even on premises, or even you can have a hybrid environment which includes both cloud and on premises. So then have engage and experience. So build UI different UIs with simple drag and drop like features, and deploy them in web and mobile application and AR experience. So have cross device platform capabilities, and then again it has a very vibrant ecosystem. So how THINGWORX empowers industry businesses to connect, build, analyze, manage, and experience. So as I said, you can connect to disparate devices and applications to enable access data from multiple data sources. You can build complete industrial IoT solutions and AR experience very quickly and easily, as drag and drop tools are available in the solution. And then analyze this industrial IoT data for having real-time insights and predictions and recommendations. Then manage performance of these connected devices, process, and systems, and rapidly build engaging and compelling visual on the cross-device user experiences. So we are going to have a look at each and every aspect of these all 5 processes one by one. So first one is connected. How you are able to connect it? Basically, technically speaking, using THINGWORX, you can connect to anything. It might be a machine, it might be a computing device, it might be equipment which works on field, it might be even human, or it might be even animal. So there are 2 categories here. One is smart connected operations and smart connected products. So whatever product which is after manufacturing, which is going on the field, which is going to perform in the field, are called as smart connected products, which has a capability of having a unique identifier, and which is capable of communicate over the network without human to human or without machine to machine interactions. So these can be called as smart connected products. Then we have smart connected operations. So whatever assembly line or manufacturing lines, or even a factory or a group of factory, when they are able to communicate with each other, then it becomes smart connected operations. So we have different ways of communicating with these different equipments and different I will refer them as assets. So one is industrial connectivity, that is a THINGWORX KEPWARE server, which is a OPC based server, where you can connect, which is having over 150 plus different industrial protocol inbuilt, and more are getting added each and every year. So using this, you can connect to different industrial machines. Then for smart connected products, you have edge micro server, SDKs like Java SDK, C++ SDK, different SDKs are available. Then industrial connectivity, again you can use the KEPWARE server here for connecting to your different devices. And then we have some connectors specifically for legacy devices. So it may be your embedded devices, it may be connected embedded devices, it may have a known protocol like OPC, UADA, like Modbus, MQTT, etc. Or you might even use a gateway, or it might be a proprietary protocol or legacy protocol. Even you can develop a connector for that as well. So we will have a look at how KEPWARE server is get connected. So on the bottom here, you can see you have your different PLC. It might be a OPC server. It can be a RTU or flow computer. It can be a database or application, sensor or actuators, which have a different drivers as per their manufacturing or OEM. So it can and having different interfaces like OPC, MQTT, REST. There are many interfaces available which are connected to different applications, SCADA, historian, MES, database application, or any ERP or IoT application. So as I said, it offers a library of more than 150 plus devices and client drivers and advanced plugins supporting those thousands of devices and data sources. It provides industrial operation data to traditional industrial automation clients using OPC and proprietary protocols. New IoT applications getting connected to new IoT applications via MQTT, REST APIs, or always-on protocol, then consistently awarded and validated by leading industry groups. So KEPWARE is a very good and known product in the industry used in today for industrial automation. So here you can see how complexity is getting increases as industries are modernizing. They consistently encounter the following obstacles. So getting connected to various devices, the quantity of data, the quality of data, and reliability on the connectivity of your data. Then shifting security and usability, and constantly changing technology. So you have these different devices from different manufacturer, different applications from different OEMs, which are connected, maybe connected to your cloud application, or your historian, or your SCADA, or you're broadcasting that data, or you're using mobile applications with different security architecture, and it is very disparate data. So it becomes very complex to handle all that data, handle this connectivity. So how KEPWARE solves this connectivity? So as I said, THINGWORX KEPWARE server is having mostly all the protocols or all the drivers available from different OEMs in the industry today. So it act as a single point connectivity to all your devices and applications, and get connected and have a proper secure and bi-directional communication. So these are the applicability of SDKs. So SDK is best option for your embedded edge devices. So whatever your asset is, which have a embedded computational capability, so there you can use SDKs. We have different language options, Java, C#. We have C++. So these kind of SDKs are available, where you can write your own code and program your edge device to communicate with the THINGWORX platform. Then we have this deployment architecture called as one-to-one connectivity, where your edge agent can connect as a single device to whatever application you are using it on premises, or you are even using it on cloud. Again, if you have any proprietary protocol or legacy protocol which is obsolete today, so you can communicate using by developing connectors using this available SDK. So, and where KEPWARE will be applicable, so embedded edge agents, again, if it might be having a gateway, or it might be having a known protocol like MQTT, Modbus, or OPC UA. In this case, you can use this KEPWARE server for getting connected to your devices. Then second stage is the build stage, where you try to build your application to visualize and analyze your IoT data which are you are getting out of your devices. So in THINGWORX, it is a thing model centric. So where you have like any asset is working on the field, or you have any machine which is on shop floor, so it's digital. It is nothing but a thing. So it is a physical machine which digital representation is represented by a thing in THINGWORX. So the thing model is a collection of entities that represent your process, your solution, or your applications. and it provides you context into your IoT data, and it is a building block for your IoT applications, and it has a structure and relationship that represent your real world objects. So here on the right you can see there are different thing shapes, thing template, and thing. So thing is nothing but a digital representation of your asset which is working on the field on shop floor. So let's say you have a tractor which is working on the field, and you want to monitor some key parameters like speed of tractor, oil level, etc., etc. So a thing will have a digital representation with similar properties like speed or whatever you want to monitor. So in order to create a multiple things, you might be end up using thing template. So if some properties are getting changed depending on the different model of your tractor, so you can embed that all that things, all that properties in your thing shape, and have a thing model centric IoT modeling. So here is a small example of appliance, a dishwasher. So here you can see a thing is having major 4 important that is property, different properties, services, event, and subscriptions. So properties like running hours of your asset, for in this case water temperature, soil level, load size. Then services like if you want to check whether washer is on or off, or you want to update it from firmware, or it is if it is having a failure you want to report that. So using services you can do this. Then you can trigger some events. If washing cycle is completed, it will trigger an event. If washing has started or a dryer has started, you can trigger some events. And using subscriptions you can subscribe to this event, and uh, and start some particular services which will able to change some properties. So subscriptions are nothing but you can have different kind of notification, like in this case notify whenever your dishwasher is ready, notify if it is out of detergent, like this. So again your application appliance can be connected to different enterprise system like operation, manufacturing, service, finance, or engineering, or sales. So how all these works? So we have a services here, uh, check wash. So whether check the plates or pans and glasses are being washed and dried. So if it is triggered, it will trigger a event that is stop dishwasher, and which will evaluate the loads, the measurement of soil level on your pan, pots, or whatever utensils you have in your dishwasher, and measure the load size of load size is again a property on your appliance. So if it becomes true, then it will again trigger trigger an event which is called as stop dishwasher. So if after checking whether your dishwasher has completed the washing, then it will trigger an event which is called as stop dishwasher, which will again trigger a service called as stop dishwasher. So this is how all these properties, services, events, and subscriptions are connected and work in conjunction. So this is Composer, where you do your IoT modeling. So application building, administrative features, it has like monitoring and logging, security, data storage, configuration. Again, for application building you have data modeling, generating your things, creating your thing templates, creating thing shapes, then authoring your application. Who should have the access to a particular application, who will be able to see the application, who will be able to access the data in that application, who will be able to trigger the services or events. Again, the visualization. So for that mashup builder is used. So here is the THINGWORX matrix multi-tenant. Let's say we have three different companies, trucking companies. So in a single platform, which it supports multiple customer across your different companies. You may have n number of environment in one server, which may have different connection servers. Connection servers are basically to manage managing your connected devices to offload the load from your main server. So connection server supports up to 10,000 connected devices. So if you are exceeding that limit, you can have another connection server which gets connected to your main server and then your applications. So here is another example for another application in healthcare. So your original equipment manufacturer, it may have its own environment. Then it may have some distributors for sales and service, etc. And then after your product is being sold, it may have different application in different places. So all these data you can manage in single solution or single platform. Then third stage is analyze. So for analyzing any data, you require different level of human input to take action. So whenever you have visibility or real-time insights over your data, so it is not applicable that machine will take automatic decision for you. It requires some time. So THINGWORX has inbuilt capability of machine learning algorithms. So you can create your model, ML model, and you can have your predictions using that. But for that, initially you need to provide some inputs to happen that. So there are four types of capabilities to descriptive analytics, where you can see what is happening. Then you can diagnostic that, so why it is happening. Then you can predict that uh, if something is going abnormal or anomaly is happening, so what will happen. Then prescriptive, so according to when you have the predictions, what will happen, you can take decisions and you can take actions. So what should I do? And this is a feedback loop. So after having a prescriptive analytics, you can take decision and take action and validate that action using machine learning algorithms. So there are two types of applications here: the platform analytics and analytic integration. So platform analytics contain descriptive services, property transformation, automated machine learning modeling, diagnostic, predictive, and prescriptive analytics. And whether analytics integration, it is a more kind of managing application. So where you can manage your all analytics models, simulate models including digital twin. Pre-built simulators are provided with some third-party integrations. Then simulation integration SDK, where you can create your own, develop your own integration to different simulation applications. So this is a typical interface of THINGWORX analytics, where you can have your data, which you import all the your data into the applications. You create different signals, and depending what type of data or what type of data in your property in your application is, it create some signals and identify automatically which signals are stronger or which property is having a data which is more capable of taking to your goal. And using that, you can create different profiles, find scenario that will result in higher or lower performances. Then this is a predictive analysis model, where you have all data in your thing model, and you build a logic using all that data in your predictive model, and you have the insights like when your particular product is going to fail or asset is going to fail, and what recommended action needs to be taken for future intelligence. And again, it has a feedback loop. Whatever actions are being taken after having the prediction, you can validate that actions. And if the actions are not good enough to have increased efficiency, you can again change that and have a feedback loop again. So it applies to machine learning, to historical data, to make predictions about future outcomes. Example use cases for that are predictive failures, predict quality of your product, determine when services needed, predict sales and risk of chance, etc. So simple analytic model for creation and deployment. So analytic builders have user interface for simple and intuitive interaction with all your data. Exposes to complex relationships in data as simple to understand information. Then simplifies the advanced analytics process and help interpret information faster and save valuable time, and publish model for use in your IoT applications. Then analytics manager is there to define and trigger analysis events within the application, map incoming data to model and create with THINGWORX or externally, and map analytic output to applications. Then we have this manage phase where you manage all your data to extend your THINGWORX platform to different applications. You might have ERP applications, you might have MES, you might have CRM applications, or you might have different devices. So our THINGWORX can get extend to all these applications, and you can connect to this application. You can manage all data from this application using MQTT or REST API, and visualize all data for different departments in your organization. So how THINGWORX flow works. So here you can see THINGWORX is already having library of connector for different third-party applications. Here in the image you can see all the applications, or if you go to PTC Marketplace, ptcmarketplace.com, you will be able to see what different connectors are available. Then you can create a workflow like triggering on any alert, what property information you should get, and depending on the information in that property, let's say if in this case, in this example, we have if fuel is less than 10%, it will automatically create a refuel service case, and which will send notification to operator who will refuel, and again after validating whether the it is being refueled or not, it will complete that workflow. And in other case is if engine temperature is greater than a specific limit, it will create an emergency service case which again get assigned to an operator who should immediately shut down that particular devices. So this kind of workflow you can develop using your existing IT systems in your organization, and you can use that data as well in THINGWORX. And again, it is very simple drag and drop kind of application. No need to have a programming knowledge for doing all these tasks. So what are the out of the box connectors we have available? So 50+ enterprises system connectors ready to use out of the box, like SAP, Salesforce, Windchill, PLM applications, Office 365, or Google applications. Then stand connectors which are based on HTTP protocol, OData, SOAP, Swagger, ODBC, SQL. So again, you can create your custom connectors using SDKs which are available with THINGWORX. So if there are some legacy systems we are using or proprietary protocols, it might have. So you can create your custom connectors and you can connect to that system as well. Then the last stage is experience stage. So where you are designing your applications. For designing applications in THINGWORX, you have something called as mashup builder. So what we call as a dashboard in THINGWORX, it is referred as mashup. So in order to build any mashups, so we have some widgets available. So mashups are the fastest way to build your IoT solutions. It allows you to see and interact with your things, and it is based on the what you see is what you get. Developing tool for creating your content. So we have different widgets, simple drag and drop kind of operations. You have properties inbuilt. You can incorporate data from your thing. Then we have the functions and different connectors. So we will have a look at each and every one. So here are some sample mashups where So let's go to the next slide. So what 65 plus out of the box widgets are available, like dial gauge or LED gauge or calendar or time series chart. Even you can integrate with your Google Maps or Open Maps, or you have uh, many more widgets are available, which are simple drag and drop kind of application operations you have to do on to create your mashup. Then we have the responsive layout as per your screen resolution. You might have a responsive layout where it will get extended as per your screen resolutions, or you may have a static layout which will be fixed. So very simple and editor based. uh, you can set orientation, justification, simple whatever operations which are available in major applications like Word and PowerPoint available today. So different types of distributions, stretching, wrapping, size growing and shrinking rules are available there. So it is very easy to use. Here are some sample mashups available. So this is the architecture. On the left hand side, you can see, so as we discussed in our connect phase, for connecting any products which work on the field called as smart connected products, we have Edge micro server for your edge devices. Then THINGWORX Edge SDKs are available there. Connectors from Maxeda is available there. Again, if you have any IoT gateway which is programmable, so using any programming language which it supports, or which you are good into, you can use that and get connected to your devices. And then for industrial devices like controllers, PLC or sensors or history and data, or even DCS systems, we can use THINGWORX KEPWARE server. Again, you can get connected to your CAD system, PLM or BIM, using our SDKs which are available. And managing all that connection, here you can see we have THINGWORX connection server, and THINGWORX Composer, THINGWORX Mashup Builders, and Persistent Provide. So all these three components becomes your THINGWORX foundation, which is nothing but the THINGWORX platform. And all these Composer, Mashup Builder, THINGWORX Flow are the component of this platform. Again, using all whatever data you are getting into your platform, you can use that data to have analytics in THINGWORX Analytics. Then you can create AR experiences using Fourier Studio. In later slides, my colleague Mr. Santosh will take you through the augmented reality. Again, to communicate with all the data and visualize that data, we have REST APIs, simple HTTP based communication. Again, we have the cross devices user platform support. It might be your desktop, it might be your laptop, your mobile devices having different operating system, iOS, Android, Windows, Linux, or any operating system available in market today. So you can build application on that. For viewing the live data into your AR experience, you can use different AR wearables like Microsoft HoloLens or VR wearables, whatever available there in the marketplace. Uh, yeah. Yes. So regarding this AR augmented reality part, my colleague is going to take you through that part. So here is the breakdown of the architecture, where you have the things or digital representation of your devices, connected things, your assets to the THINGWORX platform. Then we have the users or clients which get connected to your application to the platform. Then platform in the application layer, here you can see the platform itself. So it contains device data from devices. Uh, So whatever data your devices are streaming, users can visualize their data using this platform. And again, all this data is being stored into different database. So THINGWORX supports to persistent database, SQL, H2, InfluxDB, etc. So these are the component of the platform THINGWORX server and THINGWORX connection server. So THINGWORX server is basically based on the Java application running in a Tomcat Apache container. So user can communicate through HTTP and REST responses, and device communication through the WebSocket, and THINGWORX connection server which supports up to 10,000 devices to manage the traffic of data to your devices. So it has separate server. It is a separate server application which is scalable out to devices connectivity, redirect to content your data to your THINGWORX platform. Starting point 1 per 40,000 connections, needs sticky sessions when operating through the load balancers. Then we have databases, as I said, H2, Postgres, Microsoft SQL Server, Azure SQL, and InfluxDB are supported databases for THINGWORX platform. So from here, for augmented reality, I will hand over to my colleague, Mr. Santosh Prasad. Thank you.
So till now, there's Raju again. So till now, we are seeing something about industrial IoT by using THINGWORX as a platform. So various connectivity methods are very much available. So before that, okay, we have, if you want to just take a bio break, you can take, or we can just continue. Ujjwal sir, can you just confirm about it? We can continue,
Yes,
sir?
yes, definitely we can continue.
Okay, sir. Okay, sir. Thank you, sir. Yeah, I'm just giving my laptop. Actually, we want to just have the more number of audience, so I'm using a single laptop here. Okay, I'm just transferring this particular presentation of experience platform that is using augmented reality to Santosh Prasad. So he'll take you out after this IoT, how we can manage it further by using this augmented reality, because most of the people are well versed with the virtual reality, where you try to go into a virtual platform. Here, physical and digital. So this is an area where the yin yang thing has come into picture. So which Santosh is going to take you out. Thank you.
Thank you, sir. Good morning, Ujjwal sir and all attendees. I will start my presentation, not now, but I'll go with one example, rather you say application of AR. Okay, so I'll show you one experience to make you understand what AR is, and maybe when I will start my presentation, then you will get to know, I mean, what is that actually. Okay, so I'll share my iPad. Let's see, I mean, you are able to see that or not. Just confirm it. Sir, are you able to see that?
Yes, yes, I can see.
So I will show you one experience, okay, and I'll explain it first. Okay. So now the use case is, say this is a process industry where I'm a service technician. I'm responsible for all the maintenance work, and rather if any work breakdown happens, then I'm also responsible for all this servicing activity also in that plant. Okay. So how this AR can help me now? So we have now I have it has not yet come. Now I have opened an experience which is a valve and valve assembly, right? Now okay. So now we have this user experience where we have certain buttons created. What happens is that some issues has been reported that some pressure drop has happened to one of the wall. based on the sensor data received, right? So I just
go to that so that they can see that numbers.
So now before going for that maintenance work or the servicing work, I should be able to find out where the problem is, right? And also I want to be prepared what could be the possible solution for that problem. So now I have just opened that data in AR or that viewer, and I will get the real data of the sensors, right? So this is one of the advantage when you are using that PTC solutions. So I will get the real sensor data. So based on that, I will get to know that where the problem is, right? Now I'll just click the button, first button, and I will just locate where the problem is. Just be patient. I mean, it's a little bit slower.
When we are trying to just work live, actually it takes some time for you to have a display. So that's the reason we're just waiting. Look at her. It is becoming very slow.
Too slow.
Sir, you're able to see the analysis.
So are you able to see something? I mean, some widgets?
I can see your screen, mobile tablet screen. I can see your tablet screen.
Okay. And that pipe and wall or something, right?
Right.
But nothing is coming beyond that, right?
Yeah.
Right.
Okay. Okay. What we'll do?
On top of the screen, I can see different widgets.
Yeah, buttons are there. 1, 2, 3, 4, right?
Right.
Now, when I click button 1, are you able to see something in the right side?
No.
Nothing is coming out.
No.
Now it is coming, right?
Now it has come.
Locate.
Yeah. So based on the issue now, I just click where is the problem, right? So I will just locate by clicking on that. Okay.
Right.
And I need to know that where the problem is. Again, slow. So I'll go with the second button, okay, and I'll just click on analyze. Just wait for some time.
AR experience fast करने के लिए इतना slow नहीं होता है बहुत ही slow.
Sir, just I'll just redo it again, okay? Just
नहीं वो iPad पे नहीं आ रहा है ना iPad पे आ रहा है तो फिर connectivity. I think the problem is with the connectivity. iPad use कर ठीक है. Let us go back.
So maybe
we'll focus it once again. We'll just go ahead with the presentation.
I'll go with the presentation, then maybe from software I'll just show you how it works, okay? Maybe because of the connectivity issue we are not able to do that. Okay. So now I mean when we are talking about that augmented reality, right? Now we have a physical thing and we have a digital thing, right? Physical means that machines are there, hardwares are there, many things are there which comes under the physical thing. Now they are digital, maybe that sensor data, or maybe you can say that CAD data, or any data which is in a digital form, right?
Now take an example of the same thing, and that pipe and valve assembly, right? We have a physical data in that form, right? And we have a digital data in CAD form, and also we have a digital data in a sensor data, right? Now both are often before that augmented reality, or maybe before you can say the IoT, right? So the data coming from that physical thing is not properly used, or maybe that cannot be used to gain more productivity towards that, to make more benefit, right? So now what AR is doing, or the augmented reality is doing, we are getting the sensor data or the physical data in form of sensors or whatever, and we are actually merging with the digital data, right? Suppose if you are doing some CAD design and the production is happened, manufacturing is been happened, right? Has been happened. Now the CAD now the now the CAD data is orphan. Now that CAD data is not used after that manufacturing happens, right? Now when we are using this kind of things, right, IoT or that augmented reality, now the sensor data coming from the physical things, we are actually making use of it, and again we can use it for some other purposes. So this kind of things is now we are into this kind of technology, right? So this is basically a PTC icon where they are have made physical and digital PND kind of. You can see that the logo is PND. So this is basically a physical digital the digital twin kind of thing, right? So now what is augmented reality? Basically we have just seen that example, that we have graphical content which we are superimposing on the live world, okay, and we communicate with that live things, and that is what augmented reality is. In virtual reality, basically you are confined to a virtual world. We are not interacting with that actual world, so that is very different than the augmented reality. And so when you are communicating with the machines or many hardwares, then you have to have this kind of technology called this augmented reality, okay. Now this is the symbol where I just explained that we are getting that physical data from the physical things, and we are processing the data, and that data can be used for other purposes, like if you want to do some maintenance work based on the sensor data, you want to locate where the problem is, something means you want to get productivity out of that the data you are getting from the physical things, right? So we are basically using all this information and using for your productivity. Now so this is the these are the things which comes under that augmented reality things. So I'll just explain in the subsequent presentation. Now, as I said, that what we have a CAD data and we have a physical data. So if you put sensors to the actual data, physical data, and then the same data can be accessed through Internet of Things, and can be used for betterment of the product, or maybe for the maintenance of the product, maybe for the servicing of the product, something like that, okay. So basically we are creating a digital twin by using that Internet of Thing. Now we have seen that now AR is growing. I mean, we have that the industry segment is growing also, because earlier it was only video games and maybe to the entertainment side, but now PTC is focusing toward that manufacturing side also, right? So if you take an example of video games, like you know that PUBG game is developed on this Fourier Studio software only, right? So so the market of video game is much more than the other industry segment, right? But again, it is that the people are more aware now about that technology, and they want to use this kind of technology for productivity, for efficiency, and many things, right? So if I talk about that value across the manufacturing side only, right? So for the design segment on manufacturing, sale, marketing, service, training, so we can use all these segments for this technology, right? If you take example of design side, we can do the design review, maybe collaborative design review also. Maybe the plant is have multiple locations, right? So people can do a design review by using this kind of technology, right? In manufacturing side also, if you want to have a maintenance work instructions, right? So everybody is not very skilled, so you can create this kind of use this kind of technology to create instruction where people can view the experiences and do that maintenance work, maybe for assembly or disassembly process. So many things. Even the customer can also create a digital brochure. They can put this augmented reality output to their website to view their product, what their product is, how it looks like. Everybody cannot put the CAD data to the website. So this kind of technology can help the companies to market their product, right? So many things are there which can be used and can be taken value, right, out of this technology. Now, if I talk about what are the components inside this AR experience, so we have to have a physical object. If you want to do some kind of maintenance work instruction or servicing instructions or maybe training instructions, so you have to have that CAD data, right? Or maybe if you want to know only the temperature or something which doesn't require, then you can skip that physical object, right? No, sorry, not physical object. We have to have physical object. This second one is 3D digital scene, like CAD image, IoT gauges, or CAD data also. So you can use this thing. So physical object plus 3D digital scene, and there will be a 2D digital layout where the interface will be designed, right? Having many buttons, images, pop-ups, maybe some other things will be there, which can you basically interact with that 2D digital overlay, and the things will happen, okay? And after that, that final layer experience will be created. So you basically use that physical object or superimpose that AR experience on that physical object, and all this 2D digital overlay will be pop up on that screen, and you basically interact inside that AR experience, okay? So the software from that PTC, the solution from PTC is Fourier Studio. Okay, so I'll just skip this. Now, Fourier Studio, basically, as I said, that it is again a solution which is based on drag and drop user interface, where we add buttons or widgets, and we don't require, the best part is we don't require, if you want to have a basic experience, then you don't have to have a development skill. But if you want to go for complex kind of thing, then maybe you can use your software skill to develop that kind of experience, right? So as I said, that that your user interface design is very simple. There is a drag and drop interface. You can create content like, as I said, that maintenance work instructions or training instructions, something like that. You can use that animations created inside that CAD thing, or maybe you can also use animation or create animation inside this Fourier Studio, right? You can use the sensor data. You can bring the sensor data inside this experience, and also the output can be in a multiple form where that end users can access this experience to view the augmented reality experience, right, on their particular devices, maybe on Android or iOS devices. When you talk about the features, so built-in widgets are there. Okay, so before publishing the data for the end users, you can also verify that the experience you have created is or maybe you want to do some modifications on that experience. So you can, before making available to the end users, you can verify your experience. And there is a very simple way to publishing. Don't have to do anything, just you have to single click on publish button. It will publish to that server, maybe cloud or on premise, and the end user can access through accessing by some kind of QR code or some logo, right? If you want to do some kind of styling also, so some CSS editing is also provided with that. And as I said, that if you want to do some kind of complex AR experience, then you can go with that JavaScript. So how it works? So we design Vuforia experience inside this Vuforia studio by using CAD data or the data whatever needed to do that, and we publish the data, right? We publish the data to the cloud, or maybe PTC provide Amazon cloud, but you can also go with your own cloud. So the data can be published to that, and the author will make sure the data can be accessed through some kind of tracking target tracking, right? So special target, right? So what end user have to do is that he has to download a app called Vuforia View from Google Play or maybe Apple Play Store. And when the user will open this app, he will ask to scan the THINGWORX or just do the special target, and that model or the experience will populate, and he can interact with that experience, right? So this is how it works basically. Okay, now when I say that experience will be created, how experience you are going to create? You just open the software, you do logins and create the projects, right? You insert that CAD data and you create a 2D canvas where you create all these buttons. I mean, insert all the widgets by drag and drop. You uh, uh, bind the buttons, the widgets with that event of that model, right? Suppose you want to play animation of that animation inside that CAD model, so you create a button like play the animation. So I create a button called play, and I'll attach this button to the model animation. So I'll bind that button with that event of the model, and when I click on the button, the animation will be played. Okay, so you decorate with your user interface by color or something by some CSS styling purpose, right? And you can publish that that experience to the cloud server. So you can publish that experience to the cloud server, and then end user will access the data, right? So this is how the experience can be created inside this Vuforia studio. So we have, I mean, two types of interface, like 2D interface and 3D interface. For this example, as I mean, we were trying to show this experience only, but this is how it is, right? We have the 2D interface has been created with lots of buttons. When you click some buttons, some event occurs and something will populate on the screen, right? So you see, and so in this case, so in this case, now what we do is, what we are doing it here is we are basically locating where the problem is, right? So after where the problem is, so we find that basically this is the problem, and we, after that, we are analyzing what is the issue. So we are seeing that there is some pressure drop at that valve, right? So now we'll come to know if there is a pressure drop. So what to do? I mean, now what to do? So now, as I said, that before coming to that location, you will be well prepared. I mean, what could be the possible solutions, right? So one of the solutions say that replacing the pump. Now technician, maybe sometimes that technician is, that skilled technician is not available, and the technician who is going maybe is not very skilled, right? In that case, there some replacing the motor, the instructions has been created in form of experience, right? So he can replace the motor by seeing these instructions, right? So first you have to close that valve, and then we have to stop that liquid flowing, and then he can replace the valve and he can verify that part is okay and everything is okay, right? So that way he can do the air I mean he can experience the air experience, right, and do the things. I mean, the use cases in this case was servicing, right? So here is example of 3D widgets, right? So when you scan the real object, so 3D widgets will be populated, and now we can.
There's a generator set basically, and generator set that by using the 3D widgets, so we are trying to directly focus onto this, and there is a same problem over here. And where exactly the problem is, we are trying to just see the problem area, and we are trying to give the animation experiences and take it forward. So there's an interactive object in a 3D space. What we are trying to do it, that is physical and digital interface. What we are trying to do it over here by using this particular experience, that is for a gen set. So here there's line 1, line 2, and how we are trying to focus it here, you have to move towards this side. So it is trying to guide you and to select the voltage handle. So you try to just go towards the other side of the way, and now here is the toggle breaker. You have to press this run button. So next go to the step 8. So we are trying to just do one after the other. So these steps are very much possible by using an interactive 3D space images. So there's a method what Santosh is trying to say about.
Now there are different output like air tracking. So the end user will going to access through this tracking options. So there are many options like main is THINGWORX. So you can see that on the screen there, you can see that there's a THINGWORX. So there will be a special target. So you don't need THINGWORX in that case. So you just have to find a plane where you can position, or you can put that air experience. So the component will be placed on the floor, right? So visually, virtually. And there is one thing called model target. So outline of the model will be used as a output. So when you scan that model with that model target, so everything will be get populated. So these are the examples basically, THINGWORX. So you can scan that THINGWORX, and then everything will get populated, and you can experience that AR, right? So all the data will come. So example of a special target. Now you just find a plane, and you can position all your experience on top of that plane, right? So this is example of special target. Now when I go with that model target, now the outline of that component will get matched with that physical object, and it will populate the experiences, right? So these are the main tracking outputs. So one of the tracking output can be used by the end users to access their experience, right? So maybe sometimes what happens is the internet connectivity is not there, then this experience can be downloaded for offline viewing also, right? So there will be option you can download for offline viewing. Now PREDICTIVE Studio is available on both two formats, like cloud hosted, the hosted by PTC, and the cloud space will be provided at Amazon Cloud, or maybe on premises. So you can provide, or you can create a server on your hardware. So both things are there. You can use any of the devices to view the experience, maybe Android or Apple devices, and maybe if you have a complex thing, or maybe if you have a budget, then you can go with this Microsoft HoloLens for better experience, right? And for 2D experience also, you can use this RealWare. So many devices are there. You can choose from one of the list, and you can experience that AR. So again, I mean, why to choose PREDICTIVE Studio? I mean, it is very easy to create, fastest way to create experience, right? So anybody can do that without the knowledge of development skill. Even that students with different don't have much of development skill can also create it. Maybe in industry also we don't find much people who are having development skills, so they can also do this kind of creating that AR experience, right? So I'll just quickly show one of the a short or demonstration. So I'll just I will create one short small AR experience. So I'll create it for mobile device. So when I access through my mobile, I can use that experience to any of the tracking target. So I'll just name it Adani, and I'll create it. So this is the interface where we can create the experience. Okay, so I'll just add one widget to so here I will add that model. So I'll select the CAD file. So I have added a model of an engine. Okay, so there is an animation inside this. What I'll do, I'll create an interface having two buttons to play that animation and to reset it. And also I will add one widget where that IoT data will come, and you can see that IoT data right on that augmented reality. Okay, so I'll go to this 2D interface and say I will add button. So as I said that this is very simple. You have to just drag and drop. So I will add two buttons. So I'll add two buttons, and I'll name this button to say play, and this button to maybe reset. Okay. So there is a sequence inside this called figure 1. Now what I'll do, I'll go to 2D environment, and I'll just select this button 1, which is nothing but play, and I will, when I click this button, what should happen? It should play the animation. So I'll click play all, and when I reset this button, click on this reset button, what should happen? It should reset this animation, right? So this is the 2 button I have created. Now when I go to this 3D environment, and I will add a 3D gauge, which will display the let's say the sensor data and the temperature of that engine. So so I'll just go to this external data. So I'll say car so login is not happening. So from here you can add that external data, right? And when it is added, then that data will be seen here on that widgets. Okay, and after that now you want to publish it for that end user. So what we'll do, we'll add a target, so that by scanning this, you can the end user can access this experience. So I will go to this experience and say, and here by one click the data can be published to the cloud server. Now before, as I said, that before going for the publish, we can verify that the experience we have created is up to mark or not. So I'll just go for the preview, and here also we can check the experience. सर हो रहा है, देखो ना यहाँ सेव हो रहा है ना प्लीज. सर तो बाहर तो कौन सा now we can click on play, and you can see that the sequence is playing. Now when I click on this reset, the sequence is getting reset. So this is how this experience or that user interface will be visible on your device. Okay, so now from here you can publish it, and after that publishing, the end user can view that. The end user can view that experience on their devices, maybe Android device or Apple devices or any other devices, right? So okay, so from here you can publish it, and then that can be viewed. Okay, so this is all from my side. Okay, maybe.
Thank you, Santosh. So now we can open for questions. So if you have any questions, you can just open up with your, you can type in the chat window, and accordingly we can just answer your questions, please. Yeah. Could you please hide your demonstration and meters? Thank you, Mr. Daksheshwara. Yeah. The ideal scenario would be we can just do it on any type of scenario here, sir. Like not only for the finished product, so ongoing product. So one thing what we try to just work out over here is in IoT we are trying to measure the information, and through AR we are going to see what exactly is happening on the physical to digital interface. So there's a method what we are trying to do with the integration between these two products. Yes, we can use it for real time. We have a solution called as Vuforia Chalk, where we can directly discuss with the end user what exactly the problem is, and the information can be posted, how exactly that can be repaired, and all that can be also used here. So real-time training simulations can be really possible here. So here, when it comes to the real world scenario, we are trying to just focus the real time scenario, like say physical body, we are going to superimpose onto the digital image. So digital image and physical image, we are going to superimpose on each other. So it's going to be as is scenario. So we are going to see both the things together. The digital and physical images are going to be seen in real time. So that's an advantage which is coming out. So AR technique actually, yeah, I can unmute you. I can unmute you, Mr. Dakshish, just a second. Yeah, Mr. Dakshish.
Thank you. Yeah, so your presentation was seriously good. My question is, it was having a sort of a SOP, which was, documented or well prepared beforehand. Now, in real world, what happens is that not exactly each and every breaker will be of same version, same type, and everything, or rather, it is not fixed exactly the way at every place. So what I'm trying to say is, when an engineer, service engineer goes there, he's attending a problem, right? He's asked that, okay, move now to, there were steps which were shown in augmented reality, that from here, move there, do this, second step, third step, fourth step, and all that. Now, what I'm saying is, when an engineer goes there, he finds that, okay, first step is as what it is showing, second step is also like that, but third step is a bit different. So will it also will this also, based on actually what it sees, what engineer sees, it will also change its step in real time, or it won't?
Okay, let me just explain you here. We are having one more module. Actually, because of time, we are unable to showcase you that, which is called as Vuforia Chalk. Okay, what exactly we try to do it is, number one, yes, in my CAD demo, what we are shown is, it is a process, it is step-by-step process. The experience has been already created, right? Now, if at all say the problem zone is in step 3, there is some problem. Now he is unable to, the engineer is unable to do it. Already my experiences which are related, my the actual say the peer is going to sit at his office and service engineer is on site. How he is going to interact with these two? Now, a peer and the engineer, they're going to sync by using Fourier chalk, on which it's just like a video call. So on a video call, he is going to mention, he is going to target, try to go to this particular place, highlight that area. So the highlighted portion will not go anywhere. It sticks to the component. Even though the engineer tries to move his mobile here and there, still the mark, what has been created, is going to get stick. So that is what is an advantage we are going to have.
No, so in that case, what you are trying to say, if situation is a bit different, still there would be some sort of a manual intervention. That is, someone from remote.
There is nothing called as artificial intelligence which comes into picture over here. So definitely a manual intervention is needed.
Okay, okay. Yeah, that's what my point was. Thank you.
Yes, sir. Yes, sir. Thank you, sir. Thank you, sir. Okay, there is a question from Mr. Venugopal. Going forward with all the digital technologies, how it can help the human to transcend just the physical experience. So this is what we are trying to say today, that IoT with AR, we are just trying to reduce the direct connectivity between the people here. So definitely the low skilled people can go to the workplace, and the high skilled engineers can guide them wherever they are. So that's how here we are just trying to work with. So there's a digital twin we are trying to speak about. So any more questions, please? I think Mr. Lakshmikant Boyer is raising his hand. I'm just unmuting you, sir. Yeah. Mr. Lakshmikant, you're self unmuted, so you can speak now. You can unmute yourself and speak. Okay. So I hope we'll just any questions are there, you can just send it to Dr. Ujjwal Patel sir, or even Swapnil or me. You can get in touch with us. Definitely we can solve the problem, so we can just answer your questions. So over to you, Ujjwal sir.
Yes, sir. Thank you so much. I hope all the participants have got the sufficient knowledge that how we can explore the IIoT and augmented reality for the implementation of different systems. So we have seen one of the promising tools in this particular area. Similarly, all the tools will be working in the exactly same manner, right? So I hope all of you have gained sufficient knowledge regarding the implementation. Thank you all. Thank you for your participation. Thank you so much.
Thank you, sir.
Thank you, sir.
Thank you. Thank you.